Welcome to Bumblebee final presentation for operating systems. This team got Elio Waga, Kevin Ogechi, Jacinta Rico, Jim Litema, and Nelson Mchonji. So on this presentation, we're going to cover the command line and the equations and the recap and the compilation. So in the command line project, use the change directory command chdir to change the directories. Then we use the host name command to identify the username, which is woof in this case. Then we navigated to desktop using the cd directory and the dir for viewing the list of directories in a certain directory. Then listing of the contents of the desktop use the command dir, and also we made a directory using the make directory command, which is mkdir. In this case, we made the directory for command project. So we also created other directories which are operating system, Java, downloads, and Python using the make directory command. And also we removed or deleted the Python directory using the rt command. So we also pushed directories using the push directory, and we push directory OS, and also we into downloads. Then we also use the pop directory. We popped the OS directory from stack. Also, we navigated to the threaded application which was downloaded from the internet, and used the echo command to create the directories. So we unzipped the threaded application zip file, and we unzip it to a directory named threaded application. So we copied the unzipped threaded application folder to the Java folder that we created earlier using the make directory command. So we copied a total of 15 files. So took a quick look at a file with the more command, and also navigated to the threaded application /dist file. Then we checked the working directory using the chdir. So we navigated to the operating system folder and edited the threaded file, and also copied the content of threaded app.bat file to multi-threaded app.bat file. So we then deleted the threaded.bat file using the tl command, and also we formed the string jar using the find string command with a /i. So again we run the threaded application from the multi-threaded bat file. Thank you. That's the end of the command line project. I'll usher in the fellow team members to handle these equations.
Okay, so I'll take you through the services of operating system. Number one, it allows for program execution. So it provides an environment where the user can conveniently run programs. Also, it allows for file system manipulation. So this process involves secondary storage, and the output of a program is written into new files or input taken from some files. It allows for communication. The processes at times need to communicate either between the processors of the same computer or other network on different computers. It also allows for error detection and I/O operation. So, on to virtual machine. I'll start by defining it. So it's basically an operating system or application environment that has been installed on an existing software, and it imitates the dedicated software. An example is a hypervisor, which emulates multiple virtual hardware platforms isolated from each other and allows machines to run Linux and Windows Server OS on the underlying physical hosts. Advantages of the virtual machine. Number one, high availability. So if one server fails, another virtual machine is spun up with minimal downtime or data loss. Also, it's familiar interfaces. Virtual machines limit the physical ones in that it is hard to differentiate. Also, it allows for backup with fast recovery. So virtual machines are able to migrate data to a working hardware in case of failure. Also, it allows for easy cloning, which is much easier to clone a virtual machine unlike a physical machine. On to the disadvantages of a virtual machine. First, it's insecure because moving applications from physical servers incurs a lot of security compromise. Oversubscription. It's possible to oversubscribe the virtual machine on physical hardware. Also, there's potential downtime where it's difficult to reboot virtual machines in case of a breakdown or failure.
Hi, my name is Jim. I'll take you through. Sorry, I'll take you through Linux bootloaders and Windows bootloaders too. So, a bootloader is a program that loads the operating system into the computer memory. So, when the computer starts, the bootloaders which are located in the master boot record loads the OS into the computer memory and starts the OS. So examples of Linux bootloaders include Grub, which is short form for Grand Unified Bootloader, Lilo, short form for Linux Loader, Loadlin, short form for Load Linux. And so Lilo, a Linux Loader is a bootloader that is used within the Linux operating system. So while restarting a machine that has Lilo installed in it, the BIOS does some tests and then hands over the control to the master boot record, whereby the Lilo resides. So the advantage of Lilo is that it fastens the booting process. So a machine which has Lilo installed in it boots faster than any other machine. The Load Linux, it runs under the DOS, and it uses the operating system driver rather than the BIOS to read the hard drive, hence no 1024 cylinder limit like with the Lilo. Disadvantages is that one must first boot DOS before loading Linux because it runs under DOS, and then also one has to do the configurations manually, which is usually a lot of tasks. So Grub Unified Bootloader, it works well with Linux, DOS, BSD, and also Windows. So during booting, one can make changes to this bootloader, that is, one can do the configurations manually. So that's an advantage over Lilo. Windows bootloader, you came across NT Loader. So NT Loader is the bootloader that has been used by all releases of Windows NT operating system and Windows XP operating system. So the boot manager replaced the NT LRD boot manager and was first introduced in Microsoft Vista.
Okay, I'll take you through bootstrap booting. And So we used an example of a system that will work with both on Windows XP and 3 different Linux distributions. So every operating system is kept on a disk, and the boot manager determines which operating system to boot at any given time. So the boot manager first, it has to run through all the different system startup. Then it determines which system to boot into. When the system boots up, boot manager are kept at known locations to be recognized. Then the boot managers, they offer a collection of systems to boot into. And finally, the boot manager, it boots into the default system if there is no specific location that has been selected. So major math
we'll take you through why it's more advantageous to have the major Mac OS rather than the general operating system. So first of all, the major Mac OS will perform specific functions when you have a dedicated OS to carry heavy Mac intensive programs. Then second is that certain unneeded aspects of the OS are done with. Because it's not a general one and a more specific one, we will do away with unneeded aspects of the OS. And then another one is that there is reduction in the size of the major Mac OS and also reduction in the amount of RAM. Another advantage is that having a kernel designed for heavy arithmetic reduces latency issues. Threads and process executions within a set time. So specific OS operating systems are designed to meet specific needs and also to work within a specified time, which is usually faster than the general one. Then only the hardware pieces required for the major Mac OS will be used, making it cheaper and more economical. And then kernel designed for only math-related functions, thus quick responses when math operations are called.
Okay, so I'll take you through multi-threaded solution. And so this is where there's a page fault on the kernel thread, and another kernel thread is switched into use. Thus there is interleaving time in useful manner. So a single threaded process, on the other hand, it's not capable of performing useful work when a page fault takes place. Therefore, in such scenarios where a program suffers from frequent page faults, or it has to wait for another system event, a multi-threaded solution performs better even on a single processor system. So virtual memory and address translation. So a virtual memory, it divides the memory into fixed sized pages and allocates in a fixed sized physical memory frames. A page table, it keeps track of the specific places where each page can be found. Thus, the operating system, it can load the given programs at any given size into the available frames. Thank you for
thank you for listening. This was Team Bumblebee.